Okay, push the button. Okay, welcome. We're going to go through a quick review of Chapter 2 so that we can be prepared for the test. I hope to finish up week 2 with Chapter 2, and then we'll be able to go through it. Everybody on your individual at each class, each table, look at this picture, okay? And I'm going to give you some time with your, let's see, why don't we do face partners, okay, to talk about the 4 forces of flight. 4 forces of flight, and what is, be able to describe the 4 forces of flight and what are the opposite forces that work against it. So, you have 1 minute starting now. Talk with your face partners. 4 forces of flight.
That's it. Lift. Weight. Drag. Ow. Thrust. Simple enough. And then weeks to 3 months.
Okay, 5 seconds. Okay, someone, please tell me what makes the plane go forward.
Thrust.
Thrust. What's the opposite of thrust?
Drag.
Drag. What makes the plane fly? Lift. What keeps it down? Excellent, excellent. So, in that scenario, has anybody heard anything lately that actually may have been indicative of some of the stuff we're talking about?
No, sir.
Anybody know about a crash?
The San Francisco crash?
The San Francisco was lately, but I'm talking about just happened 2 days ago. FedEx in Montgomery, Alabama, which I actually I've flown into this airport quite a few times in my Cessna. Actually, I used to haul around generals in a Cessna. But the bottom line is, just like we were talking about the other day, how does weight affect flight?
They didn't tie it down.
They talked about the fact that the plane crashed because of a potential shifting of the luggage. Not the luggage, the weight. And this is UPS. Don't you think they have probably huge containers they throw all the boxes in, and they're heavy? And if they shift or have too much weight, the center of gravity changes. They are underpowered because you have too much lift, too much weight, not enough lifties, and the plane crashes. So these are exactly what we were talking about yesterday. It's kind of eerie, actually. Plane crashed in the morning on Wednesday, and Wednesday we're talking about planes flying because of the weight. So 2 people died. That's really sad. And but it could have come down just to literally, like I was saying, a maintenance person not doing the job or having a bad day and messing up. Okay. We talked about the thrust of engines. We're actually hopefully going to go visit Embry-Riddle and see something about rocket engines. We'll go into a little more detail later on about the different types of engines. When we start flying, the angle of attack. When we go slower, what happens to the angle of attack?
It goes higher.
It increases, exactly right. So when you're actually slowing down to land at a slower airspeed, the plane is actually tilted up with a higher angle of attack to increase more lift to a certain point. If you get over that critical angle of attack, it stalls and falls. Yes, sir. Did you ask a question?
No, I was just simulating.
Oh, you're playing. Okay, you play with your hands. All pilots have to play with their hands. Everybody play with their hands, up and down. There I'm. That's what you do. Colonel Peoples is playing with his hands. Okay, we talked about this yesterday. Drag, and this is obviously a good picture here, right on your page of all the different
What page, sir?
Angle of attack. What page is that on, guys? There you go, 27. This is kind of important for the big picture. If you be able to know about how the angle of attack affects your drag. And then also, this is pretty advanced, but this is something that you will know because it'll come up the next chapter, is there are different types of drag. Wow, different types of drag. Look on page 29. They talk about form drag, meaning antennas that stick out of the aircraft. Of course, that's going to be sticking out there just like your hand out the car. It's going to cause drag. Interference drag, meaning where the different parts of the aircraft are joined is not smooth, and it causes drag. And skin friction drag, and this is also very interesting. Skin friction. Anybody ever gotten on an airplane, like commercial airlines, and right before you get on the plane, sort of look down the actual skin of the plane and see how smooth it is? I mean, when these airplane parts are riveted, and they're not riveted, but when they're connected, then you're covered up with incredibly smooth paint, mini paint jobs, so it's really, really smooth. And that's the airlines, okay, because they want to save money with gas and everything else, and that's right here, skin friction. What was really interesting is when in the 1990s, in the middle of the Cold War, we were worried about fighting Russia, and we were really scared of their planes, because there were a lot of spies over there and said, oh, these planes are so fantastic. And then somehow we got some of their planes, and we realized that their skin friction was huge. They didn't think about smoothing off the outside of the plane. They put a rivet, and it'd just be a bump there, times 20,000, or however many, connect the planes. And their efficiency was very, very little. The other thing, that when you have a plane and you have a skin friction and you have a bump there, what does that do to the radar cross-section of a plane?
It makes it bigger.
It makes it bigger, very much bigger. And we can actually get to this later on. I'll tell you all about stealth. But basically, the smoother the plane is, the less radar cross-section it has, and the smoother and the more secret it is. So imagine their top planes being as rough, as horrible as can be, which was good for us because we could see them far out, and we could engage them farther out. Okay, so this is something rather important. Look at this. Wingtip vortices.
Looks like an angel.
Yeah, it looks like it. That's last part of the chapter here, page 30. I think that is a cool picture.
It's like a monster from like...
Well, do you understand what that is? What is that fun picture? Yes, sir.
Like flares.
It is flares, but why does it look so weird?
The vortices.
Well, what is a vortice?
It's where the plane goes and it's like the airflow kind of.
What? Yes, sir.
The air goes down the side of the wings and hits not moving air, so it twirls it up.
Well, this is the exact picture of what happens in every plane at the end of the tip of the wing. The wind, the wind's going fast over the top, slow on the bottom, high pressure, low pressure. But what happens at the end of the wing? So it's doing perfectly, but at the end of the wing, the vortices are the airflow combining and looking just like that. That's a perfect picture, actually. That top part where these little curlicues are the end of the wings. And look at that plane. I'm pretty sure that's a C5, right?
C-17.
C-17? Okay, I'm sorry, I can't really see from here.
Is that...
C-17, but the point is, you see the curlicues, those are called vortices.
Is that the plane that did it?
Yes, I mean, that's exactly the plane that did it. And to get even farther in advance, everybody turn to page 41. I will jump ahead. And look at that. Has anybody ever seen winglets on the outside of planes? If you look at planes, they either have no winglets, like I'm pointing to here on the picture, and that is exactly what produced those funky looking wing vortices. But somewhere along the way in the last 20 years, they figured if they turn the end of the wing up and put in a winglet on it, and they're actually kits. They take off the end of the wing and they stick on this other winglet that has a stick up. So it's like this. It gets rid of the vortice. And so you don't have that curling around, which is inefficient, and that is drag. What you're looking in this picture is actually drag, and so it's pretty cool for your generation to look out there when you're flying and see if the wing tips of the aircraft, and I know Southwest Airlines was one of the first to do it because they wanted to save money, so they're decreasing the drag by putting wing tips on every plane, and that gets it more miles per gallon, and literally that's what they're doing. Winglets reduced induced drag component. And so it's right there in your book. It's really important to think about that because that's saving you money and saving everybody else money. But this is a cool picture that's right there in your book that shows the exact example of induced drag. Because every one of those whirling around of wind is drag that hurts you when you're flying. Okay, that is the end of Chapter 2. And we will want to make sure that we realize how lift is generated. We want to talk about the 4 forces of flight. We talked about drag, slowing down an aircraft, vortices, induced drag, and thrust. So that will conclude Chapter 2. Turn it off there, please.
Me?
Yes.